In today's class, we'll be solving questions on electromagnetic field. On our advice, before watching this video, try to watch the previous videos on electromagnetic field, that is electromagnetic force and electromagnetic induction. So the first question here says, which of the following does not use the magnetic effect of current? A telephone receiver. In a receiver we have magnet. So although what we have there is a soft iron core, so when there is current flowing, what happens? Magnetism will occur. So it is part. The lead acid accumulator, it has nothing to do with, it is a chemical effect. So by converting chemical energy to electrical energy. So it has nothing to do with magnetism. So the answer is B. For an induction coil, it is an electromagnetic induction device. So for a moving coil galvanometer, it works based on the principle of what? Force experienced by a current carrying the conductor. So that is also what? Movement due to what? Magnetic effect of current. So next, which part of a DC generator converts an AC in the armature to the external to DC? Okay. Which part of a DC generator converts an AC in the armature to in the external circuit? So in short, we ask which part of DC generator. For a DC generator, it doesn't have a slip ring. Yeah, slip rings are for what? AC generator. So there is no part of DC generator that has a slip ring. So the answer is what? Which part of which part converts? So which part converts is actually the commutator. So commutator, the split ring commutator. So whenever you see commutator, just know that we're referring to split ring commutator. So the split ring is responsible to convert what? The AC to DC. Next, electrical power is transmitted at a high voltage rather than low voltage because of the amount of energy lost due to, yes, the answer is A, heat dissipation rather. So the heat generator is I square RT. So if voltage is high, current is low. If current is low, the heat generator will be lower. So but if the voltage is low, current is high. If current is high, the heat generator is higher. So it has nothing to do with eddy current. It's not about excessive current discharge or voltage discharge. It due to what? Heat dissipation. Next, induced EMF are best explained using Ohm's law. Has nothing to do with induction. Faraday's law, although it explains the factors that affect how the EMF is produced, but the law that actually explains in detail how they are formed is Lenz's law. Lenz's law is an energy conservative law. So ordinarily, when we look at induced EMF, it's as though we are creating new energy. But Lenz's law is telling us we are not creating energy. So it explains the basis. Although Faraday gave us the formula, the principle at which you can get the value of the EMF. Next, in measuring high frequency AC, the instrument used is, that should be hot wire ammeter. Yes, hot wire ammeter, due to the fact that it works based on the principle of heating effects of current. So even if the current is alternating, it has high frequency, it will not affect the fact that it will generate heat. So the answer is hot wire ammeter. Next, the main purpose of transformer in an AC radio set is to what dash. We don't use transformer to increase power. It has nothing to do with increase. It only transfer power. And in fact, no transformer can increase power. The power drops due to losses. Convert energy from AC to DC when it's not electrifier. Only electrifier convert, and it doesn't convert the energy. It converts the AC current to DC current. Sorry, alternating current to direct current. Next, step down the voltage. Yes, the answer is step down the voltage. Transformer are used to what? Step down voltage in radio. Because the input voltage is usually high, so the transformer inside needs to step it down. Next, a transformer is rated 240 volts, meaning the maximum you can take in the primary is 240. That's what? Voltage in primary coil is 240 volts. If the primary coils is 4,000, that is NP. If NP is 4,000 tons, and the secondary voltage, that is VS, is 12 volts, determine the number of turns in the secondary. We are looking for NS. recall during the course of lecture, we said the turn ratio is number of coil in secondary to the number of coil in primary, same thing as the voltage in secondary to voltage in primary, or current is primary to current is secondary. In this case, we have nothing to do with current, so we'll focus on this. Our aim is to look for NS. From here, you make NS a subject. Secondary, turns becomes NP VS VP. So NP is 4,000, VS is 12, VP is 240. These zeros takes away 12A1, 12A2. 2 in 400 are what? 200 tons. Next, which of the following devices may be used to step up voltage in a DC circuit? If you have a DC circuit, first we want to step up voltage to increase voltage. Generator has nothing to do with stepping up voltage. Generator only generates or convert mechanical energy to electrical energy. So this cannot be the answer. What a wattmeter is just to measure power, so it has nothing to do here. So we have two options: step up transformer and induction coil. Although you might say step up transformer can be used to step up voltage, yes, we can use a step up transformer to step up voltage, but it can only step up AC voltage, not DC. So induction coil can be used to step up a DC, voltage, not AC. Let's say direct current. So the answer is induction coil. D is the correct answer. Okay, the next question here from 2043. Now 43. The magnetic flux in a coil having 200 turns. The number of turns is 200. Changes at the time rate of 0.08 Weber per seconds. That is actually the rate of change of what? Magnetic flux. Given to be 0.08 Weber per second. So the question says the induced EMF is, you are looking for the induced EMF. So what's induced EMF? According to Faraday, it says the induced EMF is what? Direct proportional to rate of what? Change of magnetic flux. And from here, E equals to. So the negative sign is only telling us the direction according to Lenz's law. From here, the E directly equals to negative sign. The N is 200. And directly we are given what? Rate of change of what? A magnetic flux 0.08. So the answer is 16 volts. Next question. If a charge ion goes through combined electric and magnetic field, that is electromagnetic field, the resultant velocity of the ion is resultant velocity. So when we started electromagnetic field, I said the electromagnetic force expressed by a charge is given as E plus what? VB, if it enters perpendicularly to the field. So in this case, we want to get the value of the velocity in terms of electrical intensity and what? Magnetic field flux, magnetic flux density. So when you observe here, we are adding E and VB. If you are adding these two in physics or in mathematics, whenever two quantities are added, it means they have the same unit. So the unit of electric field intensity is same thing as what? The product of the velocity and magnetic flux density. So from here, if we make V the subject, V becomes E over B. So the answer is what? A. So people might want to go for option D. Option D is drawn because we cannot subtract a quantity from another if they don't have the same unit. We cannot remove velocity from acceleration or distance from time. No. But we can multiply or divide two different quantities to get a new quantity, but we cannot add or subtract if they do not have the same unit. So the answer is A. Next, a transformer which produces a transformer which can produce 8 volts from 240 volts, meaning the secondary voltage is 8 volts when the primary is 240 volts. As an efficiency, the efficiency is 80%. If the current in the secondary coil, that's IS, is 15 amperes, what is the second? Find the current in the primary coil. You are looking for IP. But note this, unlike the previous question, this transformer is not ideal. It's not 100% efficient. So you have to recall that the efficiency of a transformer is the ratio of the output voltage, that's the output power PS over what? PP. So that's power output over power. So in this case 80%, that's 80 over 100 equals to, so for secondary power, that's ISVS. We know IS, we know VS. So that's what? IS is 15, VS is 8, that's 15 times 8. 15 times 8 over, for the primary, that will be IPVP. We are looking for IP, but VP is going to be 240. So from here we can get IP. These zeros takes this zero. So if we make IP the subject, IP becomes 10 times 15 times 8 over 8 times 240. You can do this yourself. This take this out. 0 cancels this. So I have 15 over 24, and here 3 is common. So IP becomes 5 over 8 amperes, which you can get in decimal. And that approximately 0.625 amperes. So next question. On an AC generator, which of the following does not apply? AC generator has a magnetic, it has a field magnet. Every generator and motor, they have field magnet. But AC generator doesn't have a commutator. Whenever you hear commutator, just know that they are referring to what? Split ring commutator. So it does not have. So the answer is what? B. It does not apply to it. It has armature, it has slip rings, and it has carbon brushes. But DC generator has split ring commutator, but it has no what? Slip rings. If you don't really understand, you can check out, the previous questions. Also, you can go and listen to the lecture. Next, on which of the following is the operation of a moving coil galvanometer base? Magnetic effect of current for a moving, no. The magnetic effect of current should be under electromagnetic induction device, not induction device. Yeah, also induction device. Next, electromagnetic induction. No. Moving coil galvanometer is not based on electromagnetic induction. So because this induction is when we convert from mechanical energy to electrical energy. But what galvanometer does is to convert electrical to mechanical, opposite. So chemical reaction doesn't have anything to do with chemical. Force on a current carrying conductor, yes, the answer is D. Force on a current carrying conductor. So if you have a current carrying conductor in a magnetic field, what happens? It moves. So the pointer in moving coil galvanometer, they rotate whenever there is what? Current flowing through to measure current. Lastly, energy, and it has nothing to do with electrical energy. Sorry for that. So the answer is D. Force on a current carrying conductor is the correct answer. The answer is D. Let's move on. Okay, next question here. Now here, the figure below shows a current I flowing in a copper wire. So this is a copper wire. Current is flowing in copper wire situated in the magnetic field existing between the pole pieces of a horseshoe magnet. This horseshoe magnet on the conductor. What will the wire experience? Although the question doesn't say that directly. The question which of following is correct, and we have options. So, but here, without that, you can get the answer. So here, what happened? We have a current carrying conductor in the magnetic field. So that's Fleming's left hand rule. So use your left hand. So this is field. The field is north to south, so you point this way. This is current, but the current is not down, the current is up. So you have to turn your hand this way. No, wrong. Exactly. So no, the current is up. No, this current actually. This current and this field will go this way. So sometimes this can be very confusing. That's why you have to be very careful. So this is the correct one. The current is up. The field going towards the south, not to south. Then the tongue point towards the what? The board. So in this case, it means the wire will experience a force that what? Move it away from the observer. If we are the observer, then this thing will go inward, so away from the observer or inside the board in this case. If it's paper, inside the paper. If it's your monitor, inside the what? Monitor. So it means this conductor will experience a force, yes, a mechanical force that will push it inward. And inward what force? That's direction of motion. So that's according to Fleming's left hand rule to get the direction of motion for a current carrying conductor in a magnetic field. Next, which of the following is not part of a DC generator? A DC generator doesn't have a transformer. It doesn't. It has a commutator, split ring, it has armature, it has field magnetic, it has nothing to do with transformer. Next, when a transformer has more secondary windings than primary, so let's say this is the primary windings, we have 1, 2, 3. Then for the secondary winding, we have 1, 2, 3, 4, 5, 6, 7, 8. So in this case, what happened? This is a step up transformer. So the answer cannot be option C. C cannot be the answer because C says step down. It cannot step down. Next, has a greater power output? No. Transformer can never have a greater power output. The power output is usually less. Unless it is ideal. If it's ideal, the maximum is that they will be equal. The primary power equals secondary power. That's for ideal case. For every other cases, the primary power will always be greater than secondary. So meaning the secondary will be less than the primary. So it cannot has a greater power. B is wrong. D increases the total energy output. No, it has not to do with energy output. So without even checking, the answer is definitely A. But if I let's say has a smaller current, what happens to step up transformer? It means the voltage here will be more than here. So let's suppose the voltage here is 2 volts, here will be 20 volts. So it step up the voltage. And listen, voltage and current, they are inverse proportional at constant power. So in this case, if the voltage increase, the current must drop. So that's why as a smaller secondary current, the answer is A. A is correct. Next, a dynamo. What's a dynamo? DC generator. Primary convert what? Mechanical energy to electrical energy. The answer is A. No caps. So A straight. The dynamo is mostly referred to as a DC generator. Then it converts mechanical energy to electrical energy. Next one. Which of the following ammeters may be used to measure alternating current? We can use moving iron ammeter, hot wire ammeter, but we cannot use moving coil galvanometer. So moving coil, when you say moving coil ammeter, it is the same thing as what? Moving coil galvanometer, just that it has been converted to what? Ammeter, by connecting a shunt in parallel with it. So a shunt is a resistor of low resistance connected in parallel in order for the galvanometer to be able to measure large current. So moving coil galvanometer or moving coil ammeter can only measure DC. It cannot measure AC. And it is not an electromagnetic what? So electromagnetic induction device. These two are electromagnetic induction device, especially the moving iron ammeter. But for this, we can classify it under electromagnetic induction device, although it mainly functions due to what? Heating effect of current. So that's why it can measure both AC and DC. But for this one, that is not, it can never be used to measure alternating current. And with this, we've come to the end of fields in general. Okay, now we are done with mechanics, we are done with thermal, we are done with wave, we are done with field. So expect atomic physics. This field takes our time, yeah. The widest part of physics is mechanics. More than 40% of physics, almost 50% is physics. While this field is taking about almost 20% or more than 20%. So this is the Baba number one, the one that has the highest number of topics. So in mechanics alone, you are having about 15 topics. So then followed by fields. So field can be taken as number 2. Then the next is wave. Wave is number 3. Followed by, let's say, between thermal and atomic, which one should we pick? I'll go with thermal. No, atomic physics as no, I'll go with atomic physics. Followed by thermal. Thermal is number 5, atomic physics is number 4. So it is not based on the difficulty, it's based on the one that has the highest number of topics. So we have mechanics, so we have wave. We have wave, so we have mechanics followed by fields, followed by waves, followed by atomic physics, followed by thermal. So if you are to neglect any part of physics, any part of this, physics in secondary school has 5 levels or 5 sections. So if you are to neglect any section, it should not be fields, it should not be mechanics. So you can still neglect thermal, but the thing is, you can neglect thermal and atomic physics. But you see these fields, you see mechanics, wave fields, never neglect. So if you master mechanics and you master fields and you can master waves, the next to master is what? Atomic, followed by thermal. Although the best is to master all. There is not, it's you taking out to master all. So my next video, in my next class, expect videos on atomic physics. Thank you very much. See you in my next class.